SQA National 5 Maths 2018 Paper 2 Question 1. Households in a city produced a total of 125,000 tonnes of waste in 2017. The total amount of waste is to fall by 2%. So there's our two numbers to start with. What is the total amount of waste expected to produce in 2020? So let's start off with the percent again. It's fallen, so it's 100% minus 2%, which is 98%. Which is 0.98. There's our multiplier. So we take our amount, 125,000, times by the multiplier of 0.98, and we need to work out the time. 2017 to 2020 is 3 years, so to the power of 3. 125,000 times 0.98 to the power of 3 is 117,649. 117,649. I'll just write tonnes, because that's our units in the question. And we're done there. SQA National 5 Maths 2018 Paper 2 Question 2 on arc length. The diagram below shows the sector of a circle, centre C. It shows the radius is 7.4, the angle is 320, and it asks us to calculate the length of the arc. So this is a straightforward one. We can just write down arc length equals angle over 360 times pi times diameter. Always write down your formula first. Your angle is 320. We've got that over 360. And we're timesing by pi. And our diameter, well, it's told us 7.4. So we need to double that. So that is 14.8. Get a mark for writing down our formula. We get a mark for getting our angle, 320 over 360. Our fraction, sorry, 320 over 360. We get a mark for our final answer, which worked out at 41.32 centimetres. And we're done there. SQA National 5 Maths 2018, Paper 2, Question 3 on vectors and the magnitude of a vector. Find R, the magnitude of a vector, 24, minus 12, and 8. So magnitude of a vector, remember, just like Pythagoras, it is Pythagoras actually. So the magnitude of R is equal to the square root of 24 squared plus minus 12 squared plus 8 squared. Now this is a calculator job, so you get your calculator and we press square root, making sure we're using brackets, 24 squared plus bracket for a minus 12 squared plus 8 squared equals 28. And we're done there. Solving inequalities. SQA National 5 Maths 2018 Paper 2 Question 4. Solve algebraic when equation 3x is less than 6 bracket x minus 1 minus 12. So it's just the same as solving equations, but sometimes there's an adjustment to be made at the end. So let's just write the 3x is less than 6 times x minus 1, because I'm expanding the bracket. And then I've got minus 12 sitting about in the end. So that's 3x is less than, well, 6 times x is 6x. 6 times minus 6 is minus 6. So I've got 6x minus 6 minus 12. Collecting the terms together, 3x is less than 6x minus 18. Tip for you here. Keep your x's positive. So it doesn't matter what side they end up on, but if you end up with a negative x, it means you're going to have to divide by a negative, which means you're going to have to do something weird about flipping the sign, which is a bit funky. So just keep your x's positive. So I'm going to move the x's over to this side. So that becomes minus 3x on both sides. And that means I'll just leave it like that for now to get 0 is less than 3x minus 18. So I need to add 18 to both sides to get rid of the 18 from the x's. 18 is less than 3x. Divide through by 3 to get 6 is less than x. And that's a fine answer. You can leave your answer like that. Or if you prefer, reading it backwards, you'll have x is greater than 6 because it's going backwards. Now, if you had put your x's on this side, you would have been divided by a negative, and this sign would have flipped into that side. So either option's fine. Now, mean and standard deviation question this time. SQA National 5 Maths 2018 Paper 2 Question 5, a standard one here. A farmer's market took place one weekend. Stallholders recorded the number of customers who visited the stall. The number of customers who visited 6 stalls on Saturday were these numbers, calculate mean and standard deviation. And then it goes on to say, on Sunday, They say and the mean number of customers visiting was 117. The standard deviation was 6.2. Make 2 comments again about Saturday and Sunday for the number of customers. So we'll do part A first, then we'll move on to part B. So the mean and standard deviation, using these numbers as our base. So we want x minus x bar squared. And our numbers go down the side. 120, 126, 125, 131, 130, 124. But our formula for standard deviation from the start of the exam paper is the square root of the sum of x minus x bar squared over n minus 1. There is another formula, but I never use it. Calculate a job for the first column, add them all up. 756. So our mean, which we can just write as x bar, we'll write the word mean, is 756 divided by 6, because there's 6 numbers. Using my calculator, that equals 126. So then the middle part is we take away 126 from each of the numbers. So that's minus 6, that's 0, that's minus 1, that is 5, that is minus 4, not just 4, sorry, and that's minus 2. And then the last column will square the numbers. 6 sixes is 36, you get 0, you get 1 ones is 1, 5 fives is 25, 4 fours is 16, and 2 twos is 4. We then add up all of the numbers and write it here as 82 because that's our key number. So now we substitute that into our formula for the standard deviation. So that means our standard deviation equals the square root of 82 divided by 5 because 1 less than the number of numbers. Using brackets, 82 divided by 5, 4.049, or if you want to round, 4.05 would be fine, and that's the number of customers. So we've got our 2 answers, and now we need to go and do part B. Part B says the mean number of customers who visit the 6 stalls on Sunday was 117, and the standard deviation 6.2. Make 2 valid comments comparing the number of customers visiting on Saturday and Sunday. So this time, we've done the mean and standard deviation, so 1 comment for the mean, 1 comment for the standard deviation. So looking at the mean first, our first number we calculated was 126. Theirs is 117. So on average, the number of customers visiting on Sunday is lower. On average is the word you always need to use. If you don't use on average, you don't get a mark. The number of customers visiting on Sunday was lower. That's enough for the SQ to get your mark, but I might just write because 117 is less than 126. You could have also said on average the number of customers visiting on Saturday was higher because 126 is bigger than 117, whatever way round you prefer. Now comparing the standard deviation. Standard deviation is all about consistency. Lower standard deviation, more consistent. So on Sunday it was 6.2. On Saturday it was 4.05, so that's bigger on Sunday. So I would say the number of customers visiting was less consistent on Sunday because 6.2 is bigger than the standard deviation I got of 4.05. Or, of course, you could say the number of customers visiting on Saturday was more consistent because 4.05 is less. National 5 Maths 2018 Paper 2 Question 6. A function is defined as f of x is 5 plus 4x. Given f of a is 73, calculate a. So this is the one where you have to solve an equation. So we've got 5 plus 4a, because it's changed the letter, equals 73. Taking away 5 from both sides, 4a equals 73, take away 5, that gives you 68. So a is 68 divided by 4, And again, you could just a calculator for this one because it is a calculator paper. But 4 goes into 6 once. 4 sevens is 28. You would get 17 as your final answer. SQA National 5 Maths 2018, Paper 2, Question 7 had a toy company makes juggling balls in the shape of a sphere with a diameter of 6.4. Calculate the volume of one juggling ball. Give your answer to two significant figures. Quite a simple question. You need to use the volume of a sphere, 4/3 pi r cubed. So that's 4/3 times pi times, and you need to remember to half that diameter. So it's 3.2 cubed. You get a mark for getting the sum, and then a mark for working it out, which is 137.2. And then a mark for rounding to two significant figures, which will be here. So I'll go 140. 140 cubic centimetres, and we're done. SQA National 5 Maths 2018, Paper 2, Question 8. Solve 7 sine x plus 2 equals 3. So I'll take away 2 from both sides to get 7 sine x equals 1. So the sine x is equal to a 7th. So I can do the inverse sine of 1/7. Using a calculator, I get 8.2 to 1 decimal place. And then cast diagram as normal. Sine is positive, so it's A and S. So I need to do 180 minus 8.2 degrees for my other answer. 180 minus 8.2 is 171.8. And we're done with our two answers. To underline both just to make sure we know what we're saying that they are answers. SQA National 5 Maths 2018, Paper 2, Question 9 had this question. Angle ABD is 75 degrees, BDC is 37, BC is 20, calculate the length of DC, and we're assuming that this is a straight line, because otherwise we can't do it. So if this is a straight line, we'll start getting some angles inside. 180 minus 75 is 105 degrees. 20 over sine 37 equals, and it says calculate the length of DC, so that's here. So I'll just call that one B because of the angle. B over sine 105. Once we get that far, then it's a case of just rearranging it. 20 times the sine of 105 equals B times the sine of 137. So dividing through by sine 37, B equals 20 sine 105 divided by sine 37 degrees. So now I just get a calculator and straight away work that one out. Get an answer for B of 32.1. Just check my units, centimetres. SQA National 5 Maths 2018, Paper 2, Question 10. Diagrams below, A to B and E to A represent vectors U and W. As you can see, U and W. It says that E to D is two lots of A to B. So this one is double that one. So that means I can immediately write down that this one here is 2U. It also tells me that E to A is two lots of C to D. So if E to A is double that one, that means that this one is half of this one. So I can immediately write down that this one is a half of W. It now says express B to C in terms of U and W. So I need to get from B to C. So I could go this way, B to C. But I can't actually, I don't know anything about that. But remember, vector routes means you can just go any direction you want. So I'm just going to start at B and go back all the way around and write up everything I've got. So B to C is equal to, starting at B, I need to go this way, that's minus U. Then this way, minus W. Then this way, plus 2U. Then this way, plus a half W. Simplifying everything else, the U's go together. Minus 1U plus 2U is just U. And then minus 1W plus a half W is minus a half W. And we're done there. We'll just put little underlines on it because they are vectors. Two planets in our solar system. The volume of Venus is 9.3 times 10 to the 11 cubic kilometres. This is 85% of the volume of Earth. Calculate the volume of Earth. Notice it does not say it's went down by 85%, it's just telling you that it's 85% of the volume of Earth. So 85% is our multiplier, okay? So 85%, change that to a decimal, 85 divided by 100, 0.85. So we now just take our number, 9.3 times 10 to the 11, divided by 0.85 to get back up to 100%. 9.3 times 10 to the power of 11 divided by 0.85, and we get a huge number. So we've got 109,411,76,470,58.82 cubic kilometres. Now, doesn't ask us to round it or anything like that, but it's not a very reasonable number. So I will, just for the sake of this, round this to the same degree of accuracy as the question, so two significant figures. So that gives me 1.1 times 10 to the power of, well, all the numbers after the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up to the decimal place, to the power of 12, and it's cubic kilometres, so kilometres cubed. Pythagoras and circles SQA in National 5 Maths 2018, paper 2, question 13. We have got this shape and we know the radius is 13, this length is 20, calculate the width. So if I knew here to here is 13, so I need this little bit here. So I can add that in, call that x, make a radius, that's 13, right angle triangle then, so that is 10. So we know that x squared equals 13 squared minus 10 squared. So x is the square root of 13 squared minus 10 squared, which equals 8.3. Not rounded, so then the width is just our radius 13 plus our 8.3 that we've just worked out to give us a final answer of 21.3 centimetres. And we're done there. Okay, last one, 2018, paper 2, question 13. Hopefully you're getting the hang of this by now. A ferry and trawler receive a request for help from a stranded yacht. On the diagram, E, F, T and blah. On the diagram, the points F, T and Y show the positions of the ferry, the trawler and the yacht. Ferry, trawler, yacht. It tells us lots of information in the bullet points. Just check that it's actually already in the diagram. So it says Fy is 7.2 kilometres, it is. Ty is 5.6, it is. Ft is 10.3, it is. And it says that F is on a bearing of 240 degrees from T. 240 degrees from T to F. Good. It says calculate the bearing of the yacht from the trawler. A little bit of a different question. This is asking us to calculate a bearing this time, not an angle. So the bearing of the yacht from the trawler. That means it's asking us, really, starting at the trawler, go north, turn all the way around, past here, up to here, so I'm facing the yacht. That's what it's asking me to calculate. Don't worry too much if you're not quite sure what it's asking you to calculate, just start off in the same way. Although in this case, as soon as you see three sides of a triangle, you should be thinking cosine rule to get an angle. So it's really just identifying which angle it's asking for. So once more time, calculate the beat of the yacht from the trawler, all the way round to the yacht. So I'm going to need this angle here. So let's just note this angle here. That's the one I'm looking for here. Cos A is equal to B squared plus C squared minus A squared over 2BC. So quite often, again, you'll probably just want to mark your angle as angle A so that you can substitute properly, or I'll always remember really that the one I'm taking away is opposite the angle and the other two are the ones that are adding. But let's just mark it A. So for clarity, so if I call that A, that is little a, and then the other two is going to be b and c, our sides. So we can then say we've got 5.6 squared plus 10.3 squared minus the 7.2 squared all over 2 times 5.6 times 10.3. That's cos A. You'll get a mark at that point for substituting correctly into the cosine rule. So there's a mark right there. So for our next mark, if we can work out either that cos A is equal to, well, it's 85.61 on the top over 115.36, or leaving that as a decimal, which would be something like 0.742, that gives us our second mark. Then looking at our third mark, calculating the angle. So A is the inverse cos of 85.61 over 115.36, or the inverse cos of this. And that gives me an angle of 42.008. 088, sorry. So there's our third mark, and then our fourth mark is for calculating the bearing. So just to remind you, the bearing is 240 plus this 42. So we can do 240 plus 42 is 282 degrees for our final mark. So Simplify Maths for 18, paper 2, question 14 on a straight line. A straight line has this equation, 2x minus 5y equals 20. Find the coordinates of the point where the line crosses the y-axis. Cuts the y-axis when x equals 0, the opposite. So y-axis when x equals 0. So I'll just sub it straight in. There's no need to rearrange here. When x equals 0, I've got 2 times 0 minus 5y equals 20. So that's minus 5y equals 20. Divided by minus 5, y is minus 4. So to put my coordinate, that as a coordinate, remember x and y, x is 0, y is minus 4, and I'm done there. Explain Simplify Maths 2018, paper 2, question 15 on algebraic fractions. Express n over n squared minus 4 divided by 3 over n minus 2. It tells us that n cannot be minus 2 and 2 because the denominator will be divided by 0 as a single fraction in simplest form. Dividing by a fraction is the same as times by its reciprocal. So times, and then the second one flips upside down. So that becomes n over n squared minus 4 times n minus 2 over 3. So now we can just times the top and times the bottom. Now when I times the top, I would not actually times it, I would keep it factorised because you're going to factorise the bottom to simplify. So that gives me n minus 2 over 3 times n squared minus 4. So far so good. But n squared minus 4 is a difference of two squares. So we can factorise n squared minus 4. Just a reminder of that one. I've got the 3 still hanging out. But double brackets, you square root the first thing, which is n. And you square root the 4, which is 2. And minus in one bracket and plus in the other. So you should notice I've got a same bracket top and bottom, so I can cancel them out. We very clearly show that by saying that that's gone and that's gone. So now we've got on the top just n, and on the bottom 3 bracket n plus 2. And there's no more way to simplify that, so we're done there. Moving on to 3D Pythagoras. Squared National 5 Maths 2018, paper 2, question 16. So this is often calculating a missing length in a 3D shape, usually with a space diagonal. Chris wants to store his umbrella in a locker. The locker is a cuboid with internal dimensions 40, 40 and 70. The umbrella is 85 metres long. He thinks it will fit in the locker from P to M. Is he correct? You should probably just put that umbrella in the locker and check himself, but let's do some maths. So we've got 40 by 40 by 70, and we want to calculate the space diagonal. So we're going to go from here, the front to the back. All you need to know is that you can do 40 squared plus 40 squared, and that will give you the diagonal of this, and then you use the diagonal of this with the height to get this, or all in one go, you can just write 40 squared plus 40 squared plus 70 squared. So that is our strategy. So whenever you're doing a space diagonal, it is the base numbers times the height, all squared, 3D. So then we need to square root that to get our answer. So it's 40 squared plus 40 squared plus 70 squared, all square rooted. If you do that, you get 90. And then just a little statement. His umbrella is 85, we got 90. So yes, because 85 centimetres is less than 90 centimetres. Done. SQA National 5 Maths 2018, Paper 2, Question 17 says, in the diagram below, AOD is a sector of a circle with centre O, and BOC is a triangle. In the sector AOD, the radius is 30 centimetres and the angle is 75 degrees. So we've got AOD, we know that this bit here is 30 centimetres. And it also says, in the triangle OBC, O to B is 38, so this whole bit's 38, so we know that's, we could put a wee 8 here, I suppose. And we know that O to C is 55, so we can draw that in there and say that that's 55 centimetres. What is it asking us? Well, it's asking us to calculate the area of a shaded region. So this is a combination of area of a sector, which is why it's in here, and area of a triangle, which is in the trigonometric section. So let's start off, we can do any one you want, but it's going to be a takeaway, because if I do the whole area of a triangle, I get all the area shaded in, but then I need to take away the area of the sector to get this shaded bit here. So it's a takeaway triangle minus sector. So let's do area of a triangle first. From the start of the exam paper, the area of a triangle is a half AB sine C. So that's 0.5 times, well, remember it's the angle and the two sides either side of the angle. So it's this side 38 and this side 55. 38 times 55 times the sine of 75 degrees. You put all that into your calculator and you get an answer of 1009.39. Bunch of other numbers, centimetres squared. So you've done your triangle, you get a mark for that. You now need to do your sector, so let's go back to our sector work. So we've got angle out of 360 times pi times r squared. So let's write that. Area of sector is our angle out of 360 times pi times, and we need to identify our radius, so let's go back up. The radius is just 30 centimetres, so it's 30 centimetres squared. So you get a mark there for identifying your fraction, and you get a mark for writing down fraction times pi times 30 squared. And if you work it out in a calculator, you get 589.04 centimetres squared. So far we have got 3 marks. There's 2 more marks. The next mark is for working out, you need to do the triangle minus the area and writing that down. So our shaded area is equal to our 1009.39 minus our 589.04. And we get a mark for just writing that down, and then a mark for our final answer, which is about 420.3 centimetres squared. And also I'm putting ... because I've not rounded, but 420 would be fine, or 420.3 centimetres squared would be fine as well. Okay, National 5 Maths 2018, Paper 2, Question 18 on similarity. A cinema sells popcorn in 2 different sized cartons. There they are shown. The small carton has 16 centimetres deep and has a volume of 576. The large is 24 centimetres deep and has a volume of 1125. Part A, show the cartons are not similar mathematically. So to show they're not similar, what we can do is find the scale factors if they were similar and work out what the volume of the large one should be, and you'll probably get a different answer. Well, you will get a different answer to what they've got as 1125 cubic centimetres. So let's start off. Part A, the linear scale factor, and I'm just going to go for the big one, is 24/16. Now we're using a calculator, so no need to simplify. Let's just go straight into the volume scale factor then. Remember, that's just 24/16 cubed. So if similar, then the volume of the big one will be equal to 24 over 16 cubed, the scale factor, times the volume of the small one, which is 576. So we'll just get a calculator and see what that answer is. So in my calculator, I use brackets for this, 24 over 16, close the bracket, press cubed, times 576. I get 1944 cubic centimetres. But the volume of the big is actually 1125. So I can write actual volume of big equals 1125 centimetres cubed. So not similar. Part B says, the large carton is redesigned so the two cartons are now mathematically similar. The volume of the large carton is 1500 cubic centimetres. Calculate the depth of the redesigned large carton. Okay, so we know that the new volume we're going to have to use is 1500 and the original is 576. So we can work out the volume scale factor, then working backwards from that find the linear scale factor to find the new depth. So we're trying to find it in the large one, so it is large over small. So for part B, our volume scale factor is 1500 over 576. So that means that our linear scale factor is working backwards the cube root, because we normally cube to get the volume scale factor. 1500 over 576. So the depth of our big carton is equal to our scale factor, cube root of 1500 over 576, times the depth of our small carton, and the depth of our small carton has stayed at 16. So again, calculate a job for that. So I need a cube root, so shift square root on my calculator. Make sure you use brackets to do your fraction. 1500 divided by 576. Close the brackets. You can either press equals then times 16 or a little arrow to get out of the square root. Times 16, and I get 22.012. .848, blah, 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 centimetres. Or you can round that to a reasonable place, let's just say 22.01 centimetres or 22. Question doesn't ask us to round, so best just to write down your unrounded answer. And we're done there.